Hello guys and welcome back to Leet Logics. This is special positions in a binary matrix problem. This is a LeetCode easy and the number for this is 1582. So in the given problem we are having an m cross n binary matrix mat and we have to return the number of special positions in the binary matrix mat. Now let's see what a special position means. So a position I comma j is called special if the matrix of I comma j is equal to 1 and all the other elements in the row I and the column j are 0. So the cell value should be equal to 1, the matrix of I and j equal to 1, and all the elements in the same row and the same column of the cell should be equal to 0. So let's see for this input, uh, the cell value 1 comma 2, all the elements in the second column are 0 except for this cell, and all the elements in the first row except for this cell are 0. This means this is a special position, and it is the only possible special position because for this one is colliding, so there can be no more special position, so the answer is 1. Now let's see example number 2. Here we have 1 1 0 0 1 1 and 2 2. So for 0 0, is there any other one in the 0th row? No. Is there any other one in the 0th column? No. So 1 is a special element. 0 0 is a special element. Now similarly for 1 1 and 2 2, there are no corresponding ones in their rows and columns. So these two are also special elements. So the number of special elements for this input becomes 3, which is the answer. Now let's come to the approach, how we are going to solve this problem. So you can also solve this problem by simply iterating over the matrix and at each point of time checking that in the current row there were how many ones and columns, but it will make the solution too complex. Instead, what you can do, first check for the rows. If the rows are satisfying the condition, then only check for columns. So let's see for this input that was the same as the example one. So first of all we'll check for the each row. So is it possible for the 0th row? Then we'll say no, because there was this. Then we come in the second row, we find 1, we check for this, is this possible? Yes. Then we'll check for the column. Only for second column. We do not need to check all the columns. We'll only need to check the column or the cell, because the row was already satisfied that there are no more ones in the row. Now then when we'll check for the column, we find that there are no other ones, so we can definitely say yes, it is a special position and increase the counter. So yes, this is how we are going to do. First check for the row, and if it is possible, then check for the columns. So let's start with the coding section, but before that, do like the video, share it with your friends and subscribe to the channel. So first of all, we will define a variable to count the special positions. So we need to define a method check row, and in the check row we'll pass the matrix and the index. This particular index is the row for which we are going to check, and if the index is greater than equal to 0 and check column. So you see we have already checked the row and now we are going to check the column. And for this we have to pass the I as well as the index, because the I and j both we have to pass for the particular cell, and if it is true then do the specials plus plus, otherwise return the specials. Now we need to define the check row and the check column functions. So private int check row, so it will take a matrix and it will take a variable I as input parameters. Initially the index will be 0, j equal to 0, j is less than mat dot I think it should be mat dot 0 dot length, because we want to see the columns. Then if the index is greater than equal to 0, we return a -1. This we return, we'll do index equal to j, and after this we can return the index. And similarly now we have to make a private boolean check column function. So it takes a matrix, it takes a I, it takes an index. So we check matrix of j and index if it is equal to 1 and j not equal to I. So we have found, in this case we have found another one in the same column, which is uh, not good for the special position matrix, so that's why we'll return a false here. And if it passes this entire loop, then it will be definitely true, it will be a special position, so we can pass here true. I think the code is complete. Now let's run for the sample test cases. The sample test cases are passed. Let's try to run for the hidden test cases as well. The hidden test cases also passed with a good time complexity and a good memory complexity. So the time complexity for this solution is O of m cross n, where m and n are the number of rows and the number of columns of the matrix. And the space complexity is actually constant, because we are not using any extra space, and we are using only the matrix which is provided to us and no extra space, so that's why the space is constant. So you can also check the C++, Python and the JavaScript code by going into the solutions panel from the LeetCode, and then you can check this solution, this one. It consists of the intuition, approach, complexity, and the code Java, C++, Python, JavaScript. And yes, remember to upvote. I hope you understood the logic. Do like the video, share it with your friends, and subscribe to the channel if you're new to the channel. Thank you for watching the video. Have a nice day.